to work this problem right here, kind of as warm up. But before we get into that one, I'm going to do a couple things real quick. I want to talk about the three different ways that we can write quadratics. So we had three different ways to write linear a day or two ago. We've got three ways or three formats for quadratics. So standard form, it's kind of what we've been seeing the last couple days. AX squared plus BX plus C. That is standard form. Okay? What information do we know if it's in standard form? Say again? Okay, if A is positive, that tells us something. We'll look at it here in a minute. Okay? Yes, sir?
We know the concavity.
Okay, we know the concavity. The A is the concavity. I think that's kind of what you're referencing. Could be positive or negative. What other information, what other point do I know? The y-intercept. The y-intercept is 0, C, whatever that is. Okay? Which is not a lot of information. Yeah, the y-intercept's good, but I need a little bit more than that. Now, recall, most of the time we want to find the vertex. The vertex is a very important part on a parabola. Okay? Anybody remember how we found the vertex from standard form last year? Negative b over 2a. Negative b over 2a is actually the axis of symmetry, which gives me the x value of the vertex. To find the y value of the vertex, what are we going to do with this negative b over 2a? When we find that answer. Take it and plug it back in. So I'm going to represent that as f of negative b over 2a, which means I'm going to go plug that back in. Okay? So that's how I find my vertex. If I wanted to find my roots, what would we have to do to find the roots here? What have we been doing the last couple of days? Okay, plug in 0 for y. Hopefully it factors. If it doesn't factor, I can use quadratic formula. I can complete the square. So those are the things that we're doing to find the roots. Okay? All right. Going to the next. If I have root form is y equals a x minus r1 times x minus r2. That would be root form. How does it look like I got from standard form to root form? I factored. So a lot of times it's referred to as factored form. Root form and factored form are the same. Okay? So what do I know right now without having to do any work? Your x-intercepts, your roots. Okay? So I know my roots. My roots would be R1, 0, and R2, 0, whatever they are then. Okay? Those would be my roots. I can get those pretty quickly. How would I find my vertex from root form? Where it touches the x-axis, those are my roots. What's in between? So if I were to plot a root there and plot a root there, there's my two roots. My vertex or my axis of symmetry would be in the middle of those two. So if I have a root here, I go to the middle, and then that's going to be my axis of symmetry, and that's where my vertex is going to be.
Is that the equidistant thing?
That's going to be equal distance there. That's going to be my axis of symmetry, and I can count it and I can find it. Okay?
So if you only had, let's say you only had one of the roots, could you just count whatever you would know?
If you knew where the vertex was, you could count the other one. Yeah. Okay. But if all I had was one root and that's the only information I had, it'd be hard to go. Okay. That's a good question. How would I find my y-intercept here?
Where it comes where it either comes down or.
Yeah, where it crosses the y-axis. Okay, good. Where it comes down here or there. Or if I'm going to do it algebraically, how can I use the equation? All y-intercepts have a 0 for the x. So I'd put x there, and go solve. Okay, we're going to do an example like that here in a second. Okay? All right, last form. Vertex form or translational form. It looks like that. So vertex form looks there. Translational form, because we can move it around, we can slide it. All of our transformations look like that as well. All right, we'll talk more about that later. Obviously, what do you know from vertex form? The vertex is H and K. Now remember, the H is going to switch signs because it's in the parentheses, and the K on the outside there. Would you know your axis of symmetry pretty quickly? It would be H, correct? All right. Now, one other thing on this one, how would you find your y-intercept? A lot of people make this mistake. A lot of people say my y-intercept is K, but that's not true. My y-intercept, I still got to plug the 0 in for X, and then I'll go evaluate it, and that would be my value. Okay? If I had the same equation and I wrote it in all three different forms up here, then the A value would be the same in all three forms. The A value stays the same throughout. Okay? What does the A value do to my parabola? Okay, widens it or shrinks it. It's a vertical stretch or vertical compression, which makes it wider or narrower. Okay? What else can the A value do? Talked about it a while ago. Up or down. Is it concave up or is it concave down? So that's the A. That's what's going to tell me there. So A is going to tell me concavity. So up or down, and it's going to tell me the vertical stretch or compression for that matter. Okay? It's going to tell me how it's changing. It's going to change my pattern. We'll talk about the pattern here in a little bit. Okay? Now, with a little bit more information like that, let's go into, we're going to graph 3 equations today and walk through the steps of that as we're going, just kind of review. Okay? All right. You have that first one that I asked you to do a while ago. All right. We're going to walk through it. And so let's take a look here. What is the format of that problem? That is in standard form. Okay? So what information, before I have to do any work, what information do I know right now? It is going to go up. Because the 2 is positive, it's going to be concave up. All right? I know that. I don't have to do any work for that. What else do I know pretty quickly without having to do any work? The y-intercept is 0. We're missing a C value. If I put a plus 0 there, it's still the same. And so my y-intercept is 0, 0. Okay? Now, the other thing that I think I know for all parabolas, for all quadratics, is the domain. The domain is? All real numbers. Okay? So from standard form, those are the things I can get pretty quick without having to do any work. Now I've got to start doing a little bit of work to get some of the other ones. What did we talk about a while ago? How do we find the axis of symmetry? What was our little formula? Negative b over 2a. So I'm going to use negative b over 2a to help me get started. So b is negative 4, so the opposite of that would be a positive 4. 2 times a is 2. So I end up getting 4 over 4. So my axis of symmetry is x equals 1. My vertex also has an x value on the axis of symmetry, so these are one and the same there. If I get one, I have the other. Okay. Now, if I know the x value for the vertex, now what? Go plug it in. So I'm going to go plug that in. 2 times 1 squared minus 4 times 1. So 1 squared is 1 times 2 is 2. Minus 4 times 1 is 4. So 2 minus 4 is negative 2. So there's my vertex. Takes a little bit of work to find that in this format here. Okay? Everybody okay so far? Now, let's go talk about the zeros. How do we find the zeros? What would do to the equation to find the zeros? Original problem. Yeah, the y is going to equal to 0. Good. And then hopefully, what do we get to do there? Hopefully we get to factor. Do they have anything in common? A 2 and an x, so I'm going to factor out a 2x. And then that leaves me an x, and that leaves me a -2. So I now have it factored. What did we say the other day? If we factor an x out, what is that?
Yeah, the x-intercept is 0.
X-intercept is 0, which is kind of already proof we've got that there as well, right? This right here is an x-intercept and a y-intercept. And so one of my zeros is also 0, 0. The other 0 is 2, 0. Okay. Now, I've got quite a bit of information here. I'm going to go put that on my graph. So I have 1, -2. There's my vertex. I have 0, 0. I have 2, 0. So I know it's going upward. So I can do a quick little sketch of my graph. My graph goes there. All right. Now that I kind of understand that, now I think I could probably get the range for this pretty quickly. What is the range here?
Y is greater than or equal to
Y is greater than or equal to -2. Where's the -2 coming from? The vertex. The vertex is always going to be either the highest part of the problem or the lowest part of the problem in quadratics. Now, one last thing before we go to the next one. Last year I spoke about a pattern. The parabolas, the quadratics have a pattern. What is the pattern that we follow when we're graphing quadratics?
1, 1, 2, 4, 3, 9.
1, 1, 2, 4, 3, 9, 4, 16. That's x squared is what that is. And what do I mean by that? I'm going to start at the vertex, and I'm going to go over 1, up 1. Okay? It's symmetric. So over 1, up 1. Go back to the vertex. Go over 2, up 4. Go over 3, up 9. So that patterns through the problem all the way through. Okay? Now, if you look here, this pattern's not being followed. Over 1, up 1, over 1, up 1, that misses. What changes the pattern? The 2 does. So my pattern got doubled. So instead of over 1, up 1, I'm over 1, up 2. I doubled it. The next point, if I want more points, I would go over 2, up, not 4, but up 8, because I'm doubling it. And I could get more points. Okay? Everybody okay on this one here? All right. Let's try another one. So for this next one, what I'd like for you to do is I'm going to give you about 30 seconds to about a minute. Copy the problem down. And I want you to see how many of the little pieces of it you can find without really having to do a lot of work. Okay? Try to find those pieces. All right, with no work. By the way, what format is this in? This is in root form. Looks like it's been factored, okay? So what do we know right now without having to do hardly any work? We know the roots. What are they? Remember, they switch when we go on to the graph, okay? What else do we know? Axis of symmetry, we'll find that here in a second. Hold tight on that one. I'm going to get to that here in just a second. I'll come back to you. We know domain, right? All real numbers. Do we know the concavity? It's up. There's a 1 out front right there. And so it's concave up. So that's what I would say we know without having to do any work. Now, I'm going to go on and graph this. So 2, 0 and -6, 0. Somebody said we can find axis of symmetry. How do we find axis of symmetry? It's in the middle, right? How far apart are 2 and -6? 8. So if I count 4 this way, 4 this way, then I'll be in the middle. What is that number? -2. So I have an axis of symmetry at -2. which means I also have the x value of the vertex is also at -2. Those are one and the same. They go together. Okay? Now, how do I find the y value of the vertex? Plug in that -2. I'm going to plug in the -2 up here in the equation. Could I multiply that out if I want to? Change it back to standard form? You could. But I can plug in just as it is. So I'm going to put a -2 in there. So -2 plus 6 is 4. All right? -2 minus 2 is a -4. And 4 times -4 is -16. Okay? So I just plugged into that equation. I actually like plugging in the factor form. I think it's pretty easy to do. All right? How about the y-intercept? How do you find the y-intercept? Plug in 0 for x. So put a 0 there, put a 0 there. That gives me 6. That gives me -2. 6 times -2 is -12. Got quite a bit of information there now. I'm going to go sketch. Already sketched the zeros. And again, this is a sketch that's perfectly fine. I've got -2, -16, which is down there. I've got 0, -12, which would be about right there. And I've got a pretty good understanding of where that graph is. Could you find that missing point that goes there?
Yeah.
Should be able to because it's symmetric, right? So I could count. I went over 2 up 4 here. So if I go over 2 up 4 there, I ought to go find, I could be able to find that point. Okay? It's asking to find if it's missing. Range.
Y is greater than or equal to -16.
Y is greater or equal to -16. Okay? Truthfully, factor form, I like factor form. I like using it because I think I can get a lot of things done pretty quickly in the problem. Okay? Any questions about it? About root form? All right, let's do one more. Same thing here. I want you to copy this equation down. I'm going to give you a little bit of time and want you to come up with some of those values. What do you know pretty quickly without having to do a lot of work? All right. What format? What format is this one? Vertex form. So automatically I should know the vertex, which is? Be careful because it's opposite of the inside of the parentheses and it's the same as the outside one. So 1, -3. If I know that, what else do I know pretty quick? Axis of symmetry. It's pretty easy. What else do I know pretty fast?
Down.
It's concave down because of that -1 out front. Good. And again, all real numbers there. Some of you are starting to put together the connection. We've talked about it before, the connection with the range. Could you tell me the range from this information that we know right now?
Y is greater than or equal to
Was what?
Yeah, I mean, it's less than.
So listen, this one flips. Why? If I were to draw a quick sketch of it, I get 1, -3, and it's going concave down. So there it is, right there, right? And that's a really fast sketch, all right? And so I have that, so I know that the vertex in this case is the greatest number in this one, so I get everything less than it works, and that's -3. Okay? All right, a couple other things here, y-intercept and zeros. Let's handle the y-intercept. Some people will go, oh, the y-intercept's -3 because it's there. That's the misconception that I was telling you a while ago. And this is what I get. I know when you're doing this on your test because you graph me the vertex and then you graph me the y-intercept right next to it, and then you get confused because you're like, that can't really happen. You understand that it can't happen, but then it's hard to draw the picture. Make sense? So how do I find the y-intercept? Plug in 0 for x. That's always my go-to. All right? If I'm looking for y-intercept, x-intercept, whatever, I'm plugging zeros in. 0 minus 1, -1, excuse me, 0 minus 1 is -1. Squared is a +1, but then it makes it back negative here. So -1 minus 3 is -4. Now, 0, -4 makes a lot more sense. That looks like where that is headed. So plug in. All right. What are my zeros? They don't have any real zeros. Now, I'm going to go through the process of solving them. One, because every time you have vertex form, you don't have no real solutions. So let's talk about how to get there if we're in this situation. So how would you solve for your zeros or for your x-intercepts in this equation? How do you find x-intercepts? Thank you. Plug in 0 for y. That's my y. So 0 equals -1, x minus 1 squared minus 3. So there's the setup. I put 0 in for y because I'm looking for an x-intercept. What would be my first move here? How would I solve for x? Add 3 to both sides. -1, x minus 1 squared. Now I'm going to divide by -1. So I get -3 equals x minus 1 squared. And the next one is square root. Now this is where it matches what I see on the picture in my opinion. If I take the square root here, square root there, plus or minus. What did we discuss yesterday about this look right here? Can't do the square root of a negative number, right? So now that's where I see my algebra matches my picture. Okay, I didn't have any roots, so I can't have any roots here. Now, how did we fix this yesterday?
Imaginary.
We put an eye on it for imaginary. So we put an eye on it like that, and then we add 1. So if I wanted to write a representation for this, it would be 1 plus or minus I square root of 3. Now, we can also say no real roots, and we see that because it doesn't ever cross the x-axis. Okay? All right, I'm going to conclude right there today. All right, here's what I want you to do. I'm going to do a little something different on the homework tonight, so have your stamp sheet out. I'm going to skip a little bit. I'm going to come back to it. We're going to skip the next box, which is what, 136, 140, 143. We're going to go to the next box, all right, and we're just going to do the first 2 pages there, 149 and 151. So those are your 2 pages for homework, all right, 149 and 131. And 149 and 151. Okay. On the first part, it says to do 1 through 4, A and B. And so I'll show you a picture of it here in a second.